Hey there, welcome back to Sober Mechanics with Mike, the show where we talk to you about everything under the sun that has to do with the automotive world while at the same time possibly not being drunk, even though last night we were. Today, we're coming back to you with that clutch job we were doing in the 1995 Ford Aspire. What had happened so far is that we had taken the transmission out, we were replacing the clutch assembly, and basically what happened is we ran out of light, ran out of effort, ran out of beer. We all put it back together, and the couch job got finished last night. Now, because we ran out of light, we weren't really able to make any good follow-up videos. So, today we're going to take our used components and actually explain kind of what went wrong with them, if you will. So, first off, let's start with what actually a clutch is. The clutch is pretty much composed of these three components. You have the flywheel, which is rotated by the engine, allowing it to transfer power to the input shaft of the transmission. Now, how it does that is via this clutch disc. And how the clutch disc transfers power to the transmission is via this pressure plate. Basically, the clutch disc is this fibrous material clutch. Well, the fibrous material in it basically takes all the energy of the rotating force between this particular surface and locks it together with this particular surface, which drives the transmission, if you will. So, what had happened is that we were experiencing a lot of noise between clutch in and clutch out, as well as excessive chatter and noise and vibration and harshness when you'd go from a stop to a go, basically, as you'd accelerate away from a stop. Now, if you actually look at the clutch disc, you'll find that there's no broken springs. The little springs in the center next to my finger, these little guys, those can cause quite a bit of vibration and noise when they do come apart. And you won't notice that there are any sort of fibrous discs that are down to the rivets, these little guys that hold the fibrous plates together to the steel center plate. But what you might actually be able to tell is, grab my screwdriver. If you look and you see that these little grooves right here, kind of like the wear patterns on your tire, once they get to the point where they're even with the clutch material, you basically should you're going to start to have problems, you're going to lose it. And it's actually very just above it by parts of a millimeter, if you will, which is really important there, which is a reason why you could say that this clutch was actually near the end of its life, going out, if you will. Now, that's the clutch disc itself, the fibrous material. Equally important is the mating surfaces of the pressure plate and the flywheel for which it rides on, because those take a lot of abuse, a ton of it. Let's start with our pressure plate. The pressure plate basically holds the clutch, this guy, to the flywheel here, in a sandwich, if you will. Now, what I want you to do is I want you to look at the surface of the flywheel, and you see these little, almost like a heat scorch pitting marks all over the place. All over the place. Big ones right there, right there. And then you'll notice in this section there really isn't that much of it, which is kind of a good thing. But basically, it's key to note those hot spots, because that's the point at which the clutch had been trying to do its job, trying to transfer the force, and was unsuccessful at doing it 100%. So instead of creating a single unit to transfer the force from the flywheel to the transmission, basically, it was slipping. The clutch disc was spinning without transferring all the power, which was causing a lot of problems. Now, an even better demonstration of how it had been slipping and causing problems is also, if you look actually at the clutch disc itself, see the difference in blued materials. Basically, this spinning freely and not making full contact had transferred enough heat to this, to the inner thing, to the springs, to actually change the color of the material. That's another note. Now, what you're going to see the most impact is in the flywheel. You'll see a ton of those hot spots all over the place. if you look in closer, what you'll notice is, you see these cross hatches right there? That's basically the look of a machine flywheel, what you'd want to see. But it almost looks like this just was an uneven surface. Maybe they had put a clutch in and never actually surfaced the flywheel. Can't really tell you for sure. All I can tell you is that it's not a factory clutch, and we have 133,000 miles, so it would make sense if we were on our second clutch or so. Now, what also is important to note, besides the various hot spots, which clearly show that it had been overheated, if you look down here, get real close in here. Wait for the camera to kind of zoom in, zoom out. Right there, you see that little mark right there? You can actually feel with my screwdriver. That's a crack. They're all over the place. Crack, 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 crack. Crack right there. And actually, there aren't any up here in that region. So, those cracks are another sign that it had been extraordinarily overheated. Now, here's the thing. What's going to overheat the clutch? What's causing this excessive harshness? I noted one thing when I was taking this all apart. The amount of free play on the clutch lever, basically the thing that operates these fingers, which, when you take these fingers and you push them in, it basically operates the spring right here and lifts up on the pressure plate, relieving the pressure on this to where it's not actually touching this, to where you can slip and move the transmission in and out of gear easily. Now, like I was saying, the clutch free play, it didn't have any free play basically, so at all times the clutch was a little bit acted on. Now, you've got to be thinking to yourself, well, there's a lot of force going on here, and I can't really even move these fingers by myself very easily, so how can only a little bit of play actually have any sort of impact? Well, the thing is that you're adjusting a steel cable hooked to a lever operated by your feet and your legs. Those muscles and that cable are way stronger than your hand just trying to move the lever. So what can easily happen is you can easily adjust it just enough to where these fingers are barely being pressed on, just maybe a millimeter or two, alleviating some of the pressure on these clutches. Now let's think about this for a second here. People get paid a lot of money to engineer stuff, so if you think about it, they're never going to make this pressure plate push more than it needs to. In the same way, they're never going to make this clutch have to take more abuse than it needs to. In the same way, they're never going to make this flywheel put out more power than the clutch and the pressure plate can handle. So, that leads us to the conversation of tolerance. There's fine tolerances for all of this, and if you don't have proper free play adjustment, basically, at the very end of your clutch cable, you want to be almost a hair loose by a few millimeters, just to where it'll fully disengage these fingers, fully engage this to fully contact that, which will prevent any of this heat cycling, cracking, glazing, overheating, chatter, noise, excessive problems, so on and so forth. Basically, that's what happened to our Ford Aspire. Now, we put it all in, drove it up and down the street, drives a lot better now, way less noise, way less chatter, still has a few problems. It's a little cheap car that basically was made in Korea, so it's what it is, it's what's going to happen, but you know, it's a really fun, it's a pretty peppy car, so not too worried about that. So, in the meantime, we'll get back to you on some later project about something else, but for right now, this has been Sober Mechanics with Mike. Thank you for going over the clutch with me. Glad we had this time together, and you know what, I'm sure I'll see you again. Take care, folks.